Hello, everybody, and welcome to Science Olympiad um, live streaming. We're going to be covering circuit lab and machines today. We did receive one question via email, and that was, what type of data would you want to gather for your tables for machines? And what type of data would you need to keep in your charts? Okay. Well, if you think about it, the key thing that you want to do, and we're going to look over here at our device. We've got our standard device here. Okay. Oops, sorry. Here it is, all fully balanced. And so what you've noticed here is I've got a class 1 lever, okay, with a counterweight. Okay. And I've got two different masses. Okay. Try to make them usually have the same materials. One thing I didn't show you previously that I'll occasionally use is you can buy this for like $3, and this is a level. I can put it right here at the fulcrum point, and it really helps me be able to tell when it's level. Saw a couple of people use these. They're useful, but I'll tell you something. After a while, by eye, you can normally tell when something's level. So it's not necessarily super required. But what you would measure if you wanted to is you would measure the mass of each of your masses. Okay. Then you would measure the distance between the fulcrum point, which right here is the pin right there. And you'll notice that my fulcrum point from there to there is exactly Actually, it'll be easier to measure underneath it. My fulcrum point is exactly at 12.5 centimeters, or 125 millimeters. Okay, and the reason why that's sort of neat, okay, and the reason why that's useful is because what I can do now is when I have two masses, I figure out which one's the heavier one. And I always put the heavier one on the fixed point. You'll notice it's on the shorter side. And then that way I can just move the lighter one along here to find out wherever it's balanced. But it being a fixed point, it makes it a lot easier for me, because now when I'm doing that, I can see, well, it goes down. So it really needs to go in further, and it needs to go about right here. About right here is where it's balanced again. Okay. And now I measure the distance, and I can see that it's 17.5. Okay. So let's look at the type of data I would now store. So if I go over here to my whiteboard here, I know what my mass 1 is in grams. I know what, actually I'm going to go down lower so it doesn't get in the way of that light. So I know what mass 1 in grams is. I know what mass 2 in grams is. Okay. I know the distance for 1, and I can do that in centimeters. And I know, since it's a fixed distance, it's always going to be 12.5 centimeters. This column will always be the same. The distance for 2 in centimeters is going to change. Okay. And so what I'll notice here is that if, let's say, that was 800 grams, and if I put a second 800 grams, so I know it's a 1-to-1 ratio, that's my actual mechanical advantage. Okay. And so my And another thing I might is my actual mechanical advantage, which is going to be force 1 divided by force 2, which equals mass 1 divided by mass 2. Okay, and the reason why that's equal is because gravity is going to be the same. My ideal mechanical advantage is actually going to be the distances. Okay, and that's going to be d2 divided by d1. So let's say this system was perfect. I know that 800 grams divided by 800 grams will give me 1. And if I know this is always 12.5 centimeters, and if it's a perfect system, it'll give me 12.5 centimeters. And then 12.5 divided by 12.5 is equal to 1. And then my efficiency, which is always the AMA divided by the IMA, and that will give me 1. Okay, so that would be an example of the types of data that I might keep track of. The efficiency data is really only good for me to know whether or not I've got a good lever that's not having a lot of loss. But in this particular case, and actually, I apologize. This is one of the problems you have with a live show. I don't have my scale to tell you the differences in masses. But let's just pretend that. So that's for a perfect. So this is for perfect or ideal. But in a real one, and I'll probably start out with 800 grams. I'll probably start off with 800 grams. And this, of course, will still be 12.5 centimeters. This distance here is usually going to be more than that. And let's see, on this particular one, it is 12.6 centimeters. And that makes sense. It needs a little bit more of a distance to make that up. Okay? And so now, if I get out my calculator, I look over here. Okay. And so equal equal 12.6 divided by 12.5. So the actual mechanical advantage is still 1 because those are exactly the same. And this is actually 1.008. Okay? And now when I divide this, it's 99.2% efficient. So was the efficiency of that particular one. So this was of that particular lever. Okay, and that's why we go metal on metal. You notice I'm at 99. I'm over 99% efficient. And generally speaking, I would then do 800 grams and 400 grams to get a 2-to-1 ratio. This will still be 12.5 centimeters. I can still calculate that's going to be exactly 2. Okay. And what you'll find is that probably my efficiency will be very similar. And then I would do 800 grams against, hold on a second, I want to do 3-to-1. 267 grams. And that's around 3. It's almost exactly 3. And that's still 12.5 centimeters. And I measure the distance, okay? And I look at the efficiency. And then I would do something like 800 grams and 200 grams. Okay, and that gives me an AMA of 4, and that's still 12.5 centimeters. And I make multiple measurements of each of these. And so that's how you get it working for 4-to-1. Now, then probably one of the questions you got for me, what do you do after that? Well, the first thing I do after that, I then do it for the in between. So I do it for 1.5, 2.5, 3.5. And then I do it for the in between that, 1.1, 1.2, 1.3, 1.4. Then I go to 1.6, 1.7. Okay. You keep making those measurements. Again, you're shooting for about 90%, 95 to 99% efficiency. If you've got all metal like that one, you're going to be very close. You track that. You can show that in charts. You can also look at your efficiency. Okay. Those will be the types of things that they're going to be looking for. What they really want you to know is how did you figure out what the ratios should be? And what you'll notice is the team, they actually made multiple measurements of 1-to-1, 2-to-1, 3-to-1, and they marked it on here. And all you're doing here is you're logging what that distance is. Again, I hope this is useful. I hope this is helpful. Do we have any other questions? We only have one person. And so I am not going to schedule the next one until sometime in January. I'm only going to do these once a month now, because we don't have anybody showing up for the Q&A. I'm assuming that the lessons are helpful and everybody's really ready. So my next one will be sometime in the middle of January. I'll be scheduling it later. Make sure you subscribe to the YouTube channel. And always go back to the national website. Look for updates on clarifications and such. Thank you so much. And everybody have a wonderful holiday and good luck.